Every challenge question then, part number 7. This is the circles chapter from book 1. Actually got a couple of interesting questions too towards the end, although the starting questions aren't really that bad. Midpoint of BC is this. That's midpoint of B to C. Now, of course, that means the x-coordinates go 7, 8, and then 9, and the y-coordinates go 11, 5, minus 1. It's just like an arithmetic series. So that's P and Q. Find the equation in a straight line joining the midpoint AB to the line M. So the midpoint of AB is just average 3 and 7 and average 5 and 11, and you get 5, 8. And then just find the equation line that goes through 5, 8, and 8, 5 by doing, if you want to, you can do M is y1 minus, y2 minus y1 over x2 minus x1. That would be one way of doing it. There are lots of other ways. And once you've got the gradient, you can then do y minus y1 equals mx minus x1 if you want to. That also works, choosing either of these points. And in any case, you get the equation line. It's just there. And then show the line part B is parallel to the line AC. So A to C has gradient, again, y2 minus y1 over x2 minus x1 will do here to find the gradient of this, which is the same gradient, so parallel. I have no idea why that question is in the circles chapter. Feel free to enlighten me in the comments below. We've got a triangle with these vertices this time. Find the perpendicular bisectors of each side of the triangle. We need the midpoint of these two coordinates to find, if we start with the perpendicular bisector of the side that goes from P to Q, the midpoint is this, and then the gradient from P to Q is minus 3 minus 9 over 3 minus 6, and then you do the negative reciprocal of that. So the gradient of this is 4, is it? And then I'm going to set up the negative reciprocal as minus a quarter, and then I can use either one of these 2 points here as x1 and y1 in this formula. You can tidy that up and you get this. You do the same thing for the Q and R and then for P and R. So I'm just going to do that very quickly because it's extremely boring. And again, has literally nothing to do with circles, so I'm confused as to why it's here. I did all of this in the previous chapter's challenge questions. I don't know whether they just ran out of ideas. But anyway, you're going to do this to find all 3 of them. Then it show all 3 perpendicular bisectors meet at a single point. So now we're going to have to set this line equals this one, and this one equals this one, and this one equals this one, and show that it's all the same thing. Although actually, I think we can get away with just doing 2 pairs, because if we solve this equals that, and we get x is this, and then we solve which one, this equals that, and we get x is the same thing, then I think I can argue that this line definitely goes to the point minus 5 over 6 something, and this line also does it, and this line also does it, and so therefore this line and this line meet at the same point. Is that enough to show that, I guess? Yeah, if I had maybe been more explicit about why coordinate. Either way, I'm just justifying the fact that I couldn't be bothered to type in the last equation and solve it. I just put in minus 5 over 6 into this line here to find this y coordinate, and I think I'm just going to pretend that I've done that correctly. I literally couldn't be bothered to do any more than that. This is called the centroid of a triangle, in case you want to do any further reading about any of its properties or anything like that. Circle with equation like this, so finally doing a circle question at least. So this is the equation, passes through this. So this means when x is 4, y is minus 5, so just put that information in and solve for k. You end up getting 2 values of k, which is 3 and 5, which you can then just put into the equation to get your 2 possible equations. I have literally no idea why that is a challenge question. Very confused. Also don't know why this is a challenge question. Can you sense that I'm getting a little bit annoyed with this entire video series already? But anyway, you're going to halve this number, and put them into the y and x brackets like this. Going to take away the squares. The center is clearly minus f minus g. And then when you move this stuff over to the other side and square root, you can clearly see the radius is this. It's not plus minus because, of course, radius has to be positive. And that's that question done. We finally get to some actually interesting questions after all of that. So this is the first one. Got a center of 7 minus 1 down here. And we've got a line that's tangent to the circle. So we can call the line y equals mx plus c, obviously, except we know c is minus 2. And then we can put mx minus 2 into here to solve for the solutions to when this graph touches this graph. And of course, if it just touches it, I've just expanded all this out, then that means that b squared minus 4ac is equal to 0. So we can rearrange this for a, for b, and for c. It doesn't matter whether I have minus a because I'm going to square it anyway, so it doesn't matter at all. That's b, that's a, and that's c. You can solve this for m. You'll get 2 values, of course, because there's one tangent like this and there's one tangent like that. You can pretend that you factorize this if you want to. I just put it in Wolfram Alpha. You get 2 solutions here. So this is clearly the m equals a half solution because the negative one would be down here, like I said. So we've got m equals a half. And we already know that the c is minus 2, and so that would be our equation of that line. Quite a cool question. Next one is also quite interesting. We have a center like this. So I just decided to draw this to get a feel for it. Radius root 10 is bigger than 3, so it must go below here and past here, just out of interest. We have two tangents that meet at the point 6 minus 1, which must be down here. This point, this circle reaches down lower than minus 1, as I said, because of the radius being a bit bigger than 3, so it looks a bit like this. And apparently this is a square, and I'm supposed to show that. So, okay, how do I do that? Well, the radius is root 10, as I've been saying. And the distance between these 2 points is 4 squared plus 2 squared, just difference in x different than y squared, Pythagoras. And these two things here are right angles because tangents meet radiuses at right angles by definition. So with all that information in, we can just do Pythagoras on this triangle down here maybe and say root 20 squared minus root 10 squared, which is of course 20 minus 10, equals root this side, which is root 10. And so, of course, this side is root 10 as well. And we have also 4 sides the same, which means it's either a square or a rhombus. I guess a rhombus is or a square is a type of rhombus. But it is a square because these are 90 degrees, which means these are as well by symmetry, and therefore this is definitely a square. Hence, find the equations with tangents. I went down a very dark alley here, doing stuff with the discriminants because it obviously is tangent to the circle, and I wrote y equals mx plus c, but then wrote c in terms of m because of this point here. But then I realized after doing a bunch of that this word hence here means that I would get 0 marks for that, even though it did work. So how do we do this hence? How do we use the fact that this is a square to work out the equation of these lines? Well, again, you can use the properties of symmetry that a square has in the sense that you can work out the center of this square just being the midpoint of these two coordinates here. And that's, of course, going to be 4, 0. And then you can say, well, by symmetry, if this point goes to the center by going 1 down and 2 across, then to get to this point down here, you go 2 down and 1 across, which will get me to 3 minus 2. And likewise up here, you go 1 across, 2 up, which will take me to there. And now to work out the equation of these two lines here, I can just do, I've got 2 points, right? So finding the equation line is not difficult at all. The gradient, I guess, is minus 1 minus 2 over 6 minus 5, which is just minus 3, I think. And then you can just plug in one of the points and you find y very quickly. And you do the same thing for these 2 points here to find this equation. And you get some answer here, which is, that should be a minus. I don't know why I unsuccessfully copied that. That should be a minus there. I don't know why I haven't must press delete on something by accident. Minus 3x plus 17 and 1/3 x plus, minus 3 will be our two answers. And we'll be done there. Good. That was actually quite a good question. Maybe the first of the entire textbook to actually be interesting. This one's also quite cool, actually. So 2 in a row is not too bad. We want to find the equation. So we've got two centers here, center 5, 3, and 10, 8. So that's fine. We're looking for the equation of this line here, which is the line where these two circles intersect. And you can find the intersectional line of two circles if they do intersect by just doing one equation minus the other one. Because what's really nice about it, and I've expanded it all out just to make this quicker to do, when you take these away, all the x squareds and all the y squareds cancel, and you just end up with the equation of a line. And so this equation here represents this line of where the possible intersections are. So that's all that is. I'm going to de-arrange this away from what I call BS form into a useful form here, like this. And then what I can do with that is to find P and Q is I can just look for the intersection between this line here and one of the two circles, because that will just get me the 2 points. So if I just substitute this y into maybe this one, it doesn't matter which one I do, obviously. And then, of course, expand everything out and collect together and stuff like that. You get this clearly factorizes to be 7 and 9, and then you can put 7 and 9 into this equation here to find the coordinates of 7, 7 and 9, 5, which is pretty cool. And then find the area of the kite APBQ. A really nice little fact about kites is that the diagonals must intersect at 90 degrees. And the reason that's really helpful in this case, the length of this diagonal here is just the distance between P and Q, which is 2 squared plus 2 squared square rooted, which of course is 2 root 2. It's just a bigger version of the 1, 1 root 2 triangle. It's the 2, 2, 2 root 2 triangle. But anyway, the length of this diagonal, which intersects at right angles because it's a kite, is 5 squared plus 5 squared, which is 5 root 2 square rooted, of course. And yeah, to work out the area of a kite, you can do half times d1 times d2, where d1 and d2 are the diagonals. Just a really cool fact to bear in mind. So to work out the area of this kite, I can just do half times this times that. This obviously cancels. Root 2 is 2, and then times 5 is 10, and we'll have our answer. That's the whole chapter done. Thanks for watching.